The end of Chapter 2 in the text goes through a brief TVM review, which I am including part of. But I decided we should review time value of money a bit more thoroughly to be sure we're all still comfortable with the methodologies and the use of your calculator. Basic concept: the notion that a dollar received today is worth more than a dollar received at some future date. Here's your basic present value of a lump sum formula. Discounting a value back to its value today times 0 based on the appropriate discount rate. Now, I'm going to show all the equations, though I assume you will all use your financial calculators for these. The basic future value formula. Future value at a point in the future. Present value times 1 plus the interest rate, quantity raised to the number of periods in the future. In a formula or in Excel, the interest rate is a decimal. These two graphs illustrate the relationship between present value and interest rates and future value and interest rates. No surprise, present value is discounting, dividing, so as the interest rate increases, the present value goes down. Future value is compounding, multiplying, so as the interest rate increases, so does the future value. Again, I'm showing the formula for the present value of an annuity, though I don't actually expect anyone to use it. We'll review the calculator settings late in this presentation. Same for the future value of an annuity. These are all the textbook formulas, which are equivalent but not presented in exactly the same manner as we saw in 331. Setting up your financial calculator. All of this is going to relate to the TI Business Analyst too. The newer versions already have periods per year set to 1, but it wouldn't hurt to check and be sure that yours is. The key inputs, the 5 TVM keys. Enter any 4, solve for the 5th. And there is our TI Business Analyst 2 Plus. We'll primarily be using those TVM keys in the highlighted row. Remember, either present value or future value must be negative. You can't have income now and have income in the future. Also recall, interest rates are entered in the calculator as whole numbers, so 5% is simply 5. Data entered in calculator registers stays unless overlaid or cleared, so it's safest to clear the registers before starting a calculation. To clear the TVM keys, you can press second, clear time value of money, or simply place a value in 4 of the 5 keys, even if one of the values is 0, and solve for the 5th. Also recall that setting your calculator to default to 4 decimal places. That's probably the best choice. Enough precision, but not too much. If you haven't already done so, let's do it now. Press the second key and format, which is down at the bottom. Enter a 4 and press enter, second, and quit. For each one of the TVM keys, there is an Excel function. You don't need to remember the exact name of the function nor the order of the parameters. If you click on the FX icon and select the appropriate function, a window will appear with the blanks for the needed parameters. Looking back at how we approached this in 331, we started with future value since it's more intuitively comfortable for most people. So I'm going to repeat that coverage here just for review. Note that 331 used N for number of periods and I for the interest rate. Our textbook in 333 is using T for the number of periods and R for the rate. Here's your basic future value formula. If you remember the old future value tables, the values in those tables are the 1 plus R raised to the n. That's what they were. In your calculator, you can compute 1 plus I, quantity raised to the n power, using the y to the x key. Check out the TVM by hand video tutorial. So here's an example of compounding. What's the future value of $100 invested at 4% for 3 years? We can find it in several ways. We could do it step by step manually, growing it each year. We could use a financial calculator. We could use Excel. Let's look first at just using the general case. There it is, $112.49. There's your general case repeated. Using the calculator, N is 3, IY is 4. Present value is a negative 100. Remember, you enter 100 and then press the plus or minus key. It's an outflow. You're investing $100. Payment is 0. You're not adding anything to it. Press compute and future value, and you get $112.49. And there's the Excel function shown at the bottom. Let's remember the important relationships about future value. For a given interest rate, the longer the time period, the higher the future value. For a given I, as n gets larger, future value gets larger. The relationship is direct, and that's intuitively comfortable. You leave your money in the bank longer, you're going to have more money. The second important relationship, for a given time period n, the higher the interest rate, the greater the future value. Again, Same thing. Higher the interest rate you earn, the more money you're going to have. So the relationship between interest rate and future value is correct. Both of those are observable looking at the formula. As I gets larger, that right component gets larger, and you're multiplying by it, so the future value gets larger. As N gets larger, that right component gets larger, you multiply by it, future value gets larger. If finding a future value is compounding, finding a present value is called discounting. Present value discounts future values to times 0, now. Finding a present value answers the question, how much do I have to invest today to have some specific amount in the future? More importantly, what's the current value of an amount to be received in the future? Why is future value worth less today than its face value? Opportunity cost. If I had the money today, I could invest it and have more than its face value in the future. The further out in the future is, the more I could have earned. Risk and uncertainty. Bird in the hand is true. Money in my hand is certain. Money promised in the future is uncertain. The more uncertain, the more risk, thus it's worth less today. The discount rate used to calculate present value is a function of both opportunity cost and risk. To find the present value equation, you start with the future value formula and simply solve for PV. This is a basic discounting formula, the opposite of compounding. For compounding, future value is greater than present value. For discounting, present value is less. You divide the future value by 1 plus the interest rate raised to the power of the number of periods. And note, dividing by 1 plus I to the n is the same as multiplying times 1 plus I to the minus n. So here's a present value example. What's the present value of $100 to be received in 3 years if the discount rate is 4%? Finding present value is discounting. There's your timeline. That describes the question. We want to find out what $100 is worth today. Using the general formula, it's worth $88.90. In your calculator, use the same technique as we use for future value. Enter 4 values and solve for the 5th. In this case, you need to enter payment as 0 to be certain, or have used clear time value of money before you started. And again, the Excel function is shown at the bottom. Looking at the important relationships for present value. For a given interest rate, the longer the period, the lower the present value. The meaning, the greater N, the larger the denominator, the smaller the result. The further in the future a cash flow will be received, the less it's worth today. So the relationship between present value and N is indirect. As one increases, the other decreases. For a given time period, the higher the interest rate, the lower the present value. The greater the interest rate, the larger the denominator, the smaller the result. The higher interest rate reflects greater opportunity cost or risk about actually receiving the cash flow in the future, making it worth less today. So the relationship between present value and N is indirect. As a refresher, here's your basic PV equation. It has 4 parts, PV, FV, I, and N. In your calculator, enter any 3 plus a 0 payment and solve for the 4th. And do not forget the sign convention. Inflows to you are positive. Outflows from you are negative. An annuity is defined as a series of equal payments, either inflows or outflows, that occur at regular intervals for a finite period of time. An ordinary annuity is one where the first payment occurs at the end of the period. This is the default setting in both your calculator and in Excel. An annuity due is one in which the first payment occurs at the beginning of each period. These timelines show the difference between an ordinary annuity on the top and an annuity due. Same number of payments, but with an annuity due, they all occur 1 period sooner. This drives a technique to solve for the value of an annuity due that we'll look at on upcoming slides. The formulas for the future value and present value of an ordinary annuity are shown on the slide. Again, I have no expectations that you'll actually use these, but I'm showing them for a reason. Future value and present value formulas for annuities due. Ordinary annuity, annuity due. Notice the difference. You can solve for an ordinary annuity and simply multiply the result by 1 plus the interest rate. This provides us with a really easy solution technique. We'll be using the TVM keys, but with annuities, the payment key is not 0. And the sign convention is very important with payment. A wrong sign on PV or FV when payment is 0 only results in the wrong sign on the other one. A wrong sign on payment can change the answer completely, not just the sign. Your calculator is capable of adjusting for valuing an annuity due by changing the default setting from end to begin, and we'll look at how to make that change. Look at your calculator display. The upper right-hand corner is blank. Your calculator is set to the default, end. To change to begin, press second BGN. It's above the payment key. Begin and end is a toggle. To change to begin, press second and set, and you'll see BGN appear in the upper right-hand corner. Press second and set again, BGN disappears and you're back to end. When you've displayed your choice, press second and quit. Note, the calculator stays set to begin until you change it back. This is great if you're continually dealing with annuities due. Not so good on a one-time basis, as you may forget to reset it to end. In Excel, we would still use the functions corresponding to the 5 TVM keys with one alteration. Type is 0 by default, which equates to end, and it can be left blank in Excel. To specify begin, type must be set to 1. We usually think of periods on the timeline as years, but they don't have to be. Period could mean months, weeks, whatever time frame is specified. It's important to remember that the interest rate, time period, and payment period must match. Annual periods, years, means the interest rate must be an annual rate and any payment is an annual payment. Monthly periods means N is the number of months. The interest rate must be a monthly rate and the payment is a monthly payment. It's sort of a least common denominator situation. Everything, with few exceptions, must be brought down to the smallest period. $50 a month is not the same as $600 a year. The sign convention is critical once payment is non-zero. These two problems are going to look the same with one major difference. In the problem on the left, payment is a positive $20, implying that we will receive $20 every year for 5 years. In the problem on the right, payment is negative, implying that we add $20 to the account every year. Big difference. Everything else about the two problems is the same except the sign of the payment. Note, the answers don't just differ by sign, they're totally different. First, let's look at an example of solving for the future value of an ordinary annuity. 3-year annuity, 4% annual rate, you deposit $100 each year. Payment is negative since you're depositing the $100. Future value will be positive. Present value is 0 because you are not starting with any money in the account. This problem looks the same but is slightly different. It's a 3-year ordinary annuity, 4% annual rate. But the question is, how much do you need to deposit, negative, now to withdraw $100 each year? N is still 3, IY is 4. Payment is a positive $100. Future value is 0 because you want to draw the account down to 0 at the end of 3 years. Compute present value. On the next 2 slides, we'll look at the same 2 examples we just covered for ordinary annuities, but analyze them as annuities due. First, look at the equation and solution in blue type. We're using the fact that an annuity due is equal to an ordinary annuity times 1 plus the discount rate. Or we can change the calculator setting to begin. And note down at the bottom in Excel, the type needs to be 1 to indicate an annuity due. Solving for the present value of an annuity due is handled in the same manner. Use the present value of an ordinary annuity times 1 plus the interest rate, or set your calculator to begin and solve. Now, let's look at uneven cash flow streams. We can solve these in several ways. We can use the basic formulas more or less by hand. We can use the TI, the TVM keys, or we can use the cash flow worksheet. Or we could use Excel. To find the present value of an uneven cash flow stream, you basically discount each cash flow appropriately and sum the values. Note that the present value formula can be presented in 2 ways, with division and with multiplication involving a negative exponent. Taking the most fundamental approach, each cash flow is discounted back to time 0. This can be done using either the formula, doing it by hand, or using the TVM keys. Simply sum up the results. That's your present value. Either of these methods will work, but they're a bit cumbersome. Fortunately, the TI Business Analyst 2 has a built-in worksheet to handle cash flow streams, the CF worksheet. To access it, press CF. Since the cash flow worksheet has a variable number of entries, it's very important that it be cleared before starting a new computation. So to clear it, you press CF, second, and clear work down at the bottom. The display will show CF0. Remember that for a value to be entered in a worksheet register, it must be keyed in and then enter pressed. If it's an outflow, you enter the value and press the plus or minus key. You must press the enter key. Think of a worksheet like a column in Excel. To move to the next cell, you move down to the next register. In the TI Business Analyst 2, press the down arrow. The display will show FO1 for you to enter the frequency of cash flow 1. If successive cash flows are the same amount, you don't have to, but you can, enter each one separately. You can use the frequency counter to tell the calculator how many cash flows in a row are the same. The default value is 1. Continue entering cash flows and frequencies until all are entered. To find the net present value of an uneven cash flow stream, press NPV. The display shows I is equal to 0, asking for the discount rate. Enter the rate, press enter and down. The display will show NPV equals 0. Press compute, and the computed NPV will be displayed. And we're going to walk through an example on the next slide. There's also a video tutorial on the cash flow worksheet that kind of walks you through the enter and down process. It might be a good idea to get your calculator and walk through this example just to remind you and make sure you're comfortable with the enter and down. Start by hitting CF and second and clear work to clear out the worksheet. Cash flow 0 for our example is 0. Press the down arrow. CF1 is 100. Enter 100, press enter and down. Frequency is 1, so you can just hit enter and down. Enter the rest of the cash flows. Press NPV. Enter the interest rate as 4. Press enter to get it in and down. And when NPV displays, press compute. Excel can also be used to solve for the present value of an uneven cash flow stream. One way would be to use the PV function individually for each cash flow and sum the results, much like using the TVM keys in the TI Business Analyst 2. Excel also has a built-in NPV function that can be used as well, but note that the range in the NPV function begins with cash flow 1, not 0. Loan amortizations make use of the TVM calculations to find the payment that will amortize a loan to 0 over a given period. The same principles apply to home loans, auto loans, any loan designed to be repaid in equal periodic payments, reducing the principal to 0. So let's walk through a simple amortization example. We're borrowing $1,000 at 4% to be repaid over 3 years. Step 1 is to find the equal annual payment. We're solving for an annuity payment. The loan amount is the present value, and it's positive since it's an inflow to you, $1,000. Future value is 0 since the loan is to be paid completely. N is 3 years, IY is 4%. Solve for payment, which will be negative since it's an outflow from you. Step 2 is to find the interest paid in the first year. It's the loan balance times the interest rate, $40. Step 3, the reduction in principal in year 1 equals the total payment minus any interest, $360.35 minus 40. So we'll apply $320.35 to principal. And the last step, the year 1 ending balance is the year 1 beginning balance minus the amount applied to principal. So the ending balance is $1,000 minus $320.35. The year 1 ending balance equals the year 2 beginning balance, and you just repeat the steps. Loan amortizations are well suited to Excel since once the first lines are set up, they can be copied down for however many periods till the loan payoff. In this short example, we only have 3 years. If done correctly, the ending balance will be 0. Note that with each payment, the amount of interest declines and the amount applied to the outstanding principal increases. There are several video tutorials posted in Blackboard that can help you review TVM and the TI Business Analyst 2 should you need them. There's an intro, there's using the TVM keys, doing TVM by hand, which means in your calculator but not using the gray keys. There's a whole video on the TI Business Analyst 2 cash flow worksheet and a basic algebra one on order of operations, PEMDAS. This ends Chapter 2. We'll go over some of the end of chapter problems in class.